Good morning, good afternoon, or maybe good night, depending on where are you sitting right now. My name is Andrea Pugedu. I'm the Technical Director at IMI REMOSA, and I welcome you at RefComm 21, the Virtual Technical Conference. During this presentation, we will speak about troubleshooting the common issues in valves and control system for FCC unit. We will share some lessons learned and some practical recommendations. I hope you will enjoy this presentation. Before proceeding with the presentation, I would like to share you a quite an official statistic about when it's most likely for you to be involved in an emergency in your plant. Because any emergency can happen anytime, but there are some times which are most likely than others. And precisely those are Christmas, your annual leave, your birthday, and your daughter's wedding. Let's start now with some more serious numbers. We tracked in the past few years the reason why the customer called us during an emergency, and we tried to classify the reason in several categories. The first one is, of course, purging malfunction. Is one of the most common issues that you may experience during operation. And in second place, we have a significant erosion of the parts. Please note that sometimes the two categories are quite more or less the same issues, because you may have erosion due to a purging malfunction, for example. Then another big problem is the lack of spare parts on stock during an emergency. All the slide valve and most of the components of the slide valve are non-standard components which are produced only after they are purchased by the customer. So no supplier has most of the spares on stock, and during an emergency this may become a real big deal and big issues. Then other issues can be, of course, related to the pipe packing or the gasket leakages. Finally, we have other type of issues which can be like valve stickings, refractory failures, and hotspot in the surfaces, especially near the cold joint, which are the connection between the valve and the pipeline. We just learned that the stuffing box is one of the most critical components in a slide valve, the one that is probably providing more issues during operation if not well maintained. And what can happen when you have a problem with the stuffing box? Actually, it can happen this. Likely, this is not the most typical level of damage you will see in a stuffing box. Normally you have much more milder leakages. Sometimes you can almost detect this. But the problem is that if you don't fix in advance and fix immediately any issues that you have with the stuffing box, you may end with something like this. In this very extreme situation, the leakage was so dangerous that it actually damaged physically the valve actuator and, of course, led to a plant shutdown. As we said, the stuffing box is one of the most critical components of a slide valve. In spite of this, the design is pretty much standard. It is composed by a set of two sets actually of graphite packing rings. Normally most of the process licensors prescribe two sets of 5 rings each, sometimes two sets of 4, which are compressed by a set of bolts. Then we have the purging port. The purging medium used is normally superheated steam, nitrogen or plant air, provided that you don't have any combustion risks in the process. Then we have the emergency sealant port, which is normally disconnected and is used only to inject a special foam in case of leakage. Please note that this type of foam is normally a last resort attempt. It may work, it may not, depending on the damage on side of stuffing box. And in the bottom, we have then 2 drains connection, which are normally used only during maintenance, but in case of emergency can be a last resort to have an additional purging or sealant injection in the stuffing box if the normal ports are plugged by catalyst backflow or some debris in the purging medium. An important tip here is to do not rely on the nominal steam condition that you may have in the datasheets of the plant, in the steam generator documentation, but please be sure that you are measuring the actual steam condition at the purging port inlet, because sometimes not complete or an incorrect heat tracing of the pipelines will cool down the steam, and so even if the steam is nominally produced in superheated condition, what you are getting at the valve port may be just hot water. This is very important. Don't rely on the nominal condition, but check at the valve port inlet. This slide is showing to what extent the damage due to an improper purging can reach. We see on the left side a stem, a slide valve stem, which is completely hollow, and so most of the part in the section is missing due to an uncontrolled purging flow with superheated steam that was actually not superheated. We see in the center side the bushing of a valve that are completely damaged by the purging and a backflow of catalyst, and some other damage in the other part of a stem. Some of you will be familiar with the blasting port that are normally used with some type of process licensor design. Those are ports that are normally installed in the bonnet cover, but also or sometimes in the top of the bottom of the bonnet surfaces. The main purpose is to avoid catalyst to accumulate on the sliding parts of the guides or also in the bonnet. Unfortunately, if the purging of this port is not controlled and is not limited to a certain amount of time or certain amount of flow, you may easily damage completely the disc and the internals, just like you see in these pictures. When no countermeasures are taken to decrease or to cope with any leakage that you may have with the stuffing box, you may end up with a damage to the actuator sections, to the driver section of the actuator, including the frame, the internal sliding components. And this, of course, will be a major safety breach for the plant, because in some of the services, the actuating system is part vital of the emergency shutdown system for the complete plant. A static purging panel is of course an upgrade compared to having nothing to inspect or to detect or to monitor what's happening in the purging. But right now the market and IMI REMOSA is able to provide something better. It's what we call the active purge system. It's a system that, differently from the static purging system, doesn't only check the values of the purging flow, but is also able to monitor, to record, and to raise alarm to control room in case any parameter of the purging is outside the nominal value. This is also for the grade or the quality of the steam. We have seen that a steam that is not in the superheated condition will rapidly destroy the valve. And sometimes we can be perfectly aware, completely aware that the purging is making is good job because the steam is in the right condition, but in reality it's not, because the heat pipe are not traced properly because the steam is humid. The IMI REMOSA active purging system has a special device that monitoring in real time and continuously the pressure and the temperature of the steam can detect if the steam is in saturation condition and raise an alarm that will allow the end user to intervene immediately by fixing the steam quality or using maybe an emergency nitrogen backup solution that will prevent any further issues with the stuffing box. I know that some of you may probably think that this type of device can be a bit too complex if compared on a single simple restriction orifice. But the consideration and the main takeaway I would like that you would like to bring home is that any damage like the one that you have seen due to an improper purging will generate a loss in business, in production, in service that is of course several order of magnitude the cost of this type of device and the complexity that you need to add to the plant. Normally, if you are using the active purge system with one of a REMOSA IMI HPU, hydraulic power control unit, all the logic will be, of course, handled and taken over by the PLC in the hydraulic control unit, but you can also have the unit as a standalone with a small dedicated PLC. If we talk about stuffing box, of course, we have also to take into account one of the most important parameters in the design of the stuffing box, which is the preload that you have to use for the packing gland in order to properly compress the graphite-based ring that are used to seal the pressure from the internal parts to the external atmosphere. This, of course, can be done on the commissioning stage, and by taking the measure of the distance from the packing flange to the stuffing box, you may have a decent idea on what type of compression you are doing on the stuffing box. Unfortunately, this holds only for the initial part of the service of the valve, because we must take into account a very important aspect. Graphite will oxidize because of the temperature. Then depending on the temperature, depending on the graphite quality, on the bindings material that are used in the packing system, on the packing by the packing vendor in the packing material, the time will be different. But it's not a matter if the graphite oxidize, it's just a matter of when. When graphite oxidize, it's basically losing volume, and so you lose the preload on the bolts. So the measure of the packing gland distance is not anymore relevant. You will have to torque furthermore the bolts to reach the proper compression. But this is very difficult to be done during the service, and there is no way to detect if the packing system is losing preload. If the packing system loses preload, no need to say that the catalyst will backflow like you see in the picture. What is the solution? This is a standard on all IMI REMOSA slide valve. It's a very easy solution. We use a live load system, and this is of course quite standard for some type of critical application, but we encapsulate the packing, the flat washer, the Bellow springs in a guiding system that is properly designed and machined in order to have the proper preload when you close the gap on the cover. So when you do the commissioning on the valve, you don't need any torque wrench, any special tool. You just need an open key to tighten the nuts until you close the gap. Then when the valve will be operating for a long time, the oxidation of the graphite will be immediately visible because you will see a gap opening in the system. All you need to do is just to tighten the gap again, and in spite of how much graphite was really missing from the packing, the system will be able to recover the proper preload, increasing by a lot the reliability of the packing system. In order to furthermore protect the components by any leakages, whatever small of catalyst, we need to take a special care, a special attention for the actuating parts, where you have mechanical components like the stem, screws, engaging system. And one easy but yet effective solution is to encapsulate the piston stem with a polymeric bellow, able to withstand the local outside temperature of the system, and avoid the catalyst deposition on the stem surfaces that may also damage not only the external component, but also the seals, internal seals of the high pressure hydraulic cylinder that is driving the valve. It's a very easy solution that can be installed on a new actuator, but also can be retrofitted during a turnaround on existing components. One final note about purging. We have seen the damages due to excess of purgings, but you may have damages also for the opposite reason, not enough purging. Normally, what can happen is to have a deposit of catalyst. So catalyst will build up in the bonnet area near the stem, and this most of the time is a source of valve sticking in the opening direction. So the valve can't open more than 30, 40% or 50%. Most of the time the reason is deposit of catalyst. Of course, your mileage may vary depending on plant to plant. We have seen a plant where the valves are very, very prone to this type of issue. In other plants, this issue is almost unknown. This depends, of course, also on the nature of the flow, on the catalyst, of the amount of steam in the process. So some external aspects that are really not really predictable by the valve OEM. But to avoid this, of course, the purging and the blasting shall be done in the properly controlled way. For this reason, we are also happy, of course, to assist the customer in providing the list, the codes for all the components, all the spare parts, and also to walk in the workshop in their stock to analyze all the existing spares. Sometimes not even the customer is completely aware on how many spares are available, the condition of the components. This is something that we recommend to do no less than 6-8 months before the turnaround, in order to allow us to then quote and provide any missing spare part. Let's talk now about actuation and control system. So we see which are the common issues in this sector. And the first place is the fluid related, the issues related to the fluid cleanliness. Okay. The components of an hydraulic control unit of the refinery are very sophisticated, and properly cleanliness of the fluid shall be ensured during commissioning, during installation. Otherwise, this may lead eventually to problems in servo valves and other sophisticated components. I could not stress more how this is important. Sometimes during the commissioning, customer complains about the long time required to flush and to filter all the system. It looks like we are losing time, we are not doing something effective, but believe and bear in mind that this is very important for avoid any shortening of the lifetime of the equipment. Then we have hydraulic leakages, and that may derive from problem with O-rings which are too old, not being replaced, and this of course is also a fair issue. We may have also erosion and corrosion issues related to the atmosphere. For example, if you have leakages, vapors, steams near the surrounding area of the hydraulic control unit, some of the component may be damaged because of this. And again, guess what? Another issue that is typical for this type of application is not to have the proper spare part on stock. We can see here some pictures about the typical issue you may have in a control system. We see, for example, in the red circle, an hydraulic flexosis which is damaged. It should have been replaced during a turnaround, during some service. It has not, and of course, this is a potential issue for the pressure. We have also a different type of issues. We can see then a pressure gauge which is not really readable because the glass has been damaged by external surrounding agents which damaged the instrument that shall be replaced. We may have then leakages in the hydraulic system, and all of this, of course, will require you to replace sometimes not very expensive component. You need just to replace an O-ring or a flexosis or again a pressure gauge. But what is important is that all the components shall be really available, or at least really supplyable. Some of the components can be or can look like stock components, and sometimes it's quite easy to find out a replacement. But especially for very old unit, when you are dealing with instrumentation, one practical tip I would like to give you is to plan ahead any spare parts, because you may have one typical component, one component that is no longer in the market. Maybe has been replaced by a newer component, maybe is not 100% compatible, and so sometimes we need to re-engineer some part in order to find out the best component to replace an old legacy component, and so it's not just a matter of procurement, but it's also a matter of engineering, and this will require time. Again, you see on the right side of this slide a spare part list with all the components properly identified. Again, we endorse and we encourage the customer to get in touch with us to review everything at least 8 months or 1 year before the turnaround, to see if all the spare parts are available, if all the spare parts can be procured in time. Also, some of these components may have sometimes a quite long lead time, and so we must avoid to reach the time of the turnaround without the proper parts being already available at site. Some other pictures here about component. We see an hydraulic manifold that was damaged by the external atmosphere, external agent. Of course, there are materials that can really withstand better this type of condition. But of course, sometimes you need to replace this with a new one in order to reach the best safety. We see again then some other components which are pressure switches or pressure indicator that have been damaged by the external atmosphere, which of course normally in a refinery is very, very, very aggressive. So what is the lesson learned? The main takeaway I would like you to bring home, or maybe you are already home, I don't know. First of all, you have to measure and figure out what is the value of a production day loss. Okay, so how much money is the plant losing? Compare this against the cost of any possible workaround, of any possible countermeasure you can have to avoid that production loss. Probably you will see things on a different way. Then you have to ask yourself, what is your maintenance plan? We may have different approaches, of course. The one is the easiest and also the most wrong one is just fix when it breaks. But when it breaks, it's too late. You will have problems, you will have downtime, you will have production losses, not to mention the safety issues, of course. Of course, then you can upgrade then and having what is called a preventive maintenance. So you have to change the part before they break up, okay, and base this on a regular schedule on real-time analytics of what is happening. But then you can also upgrade more and go on a predictive base, analyzing what is going to happen in your plant, basing on the trend of the damages, on the condition-based maintenance, and of course, also for obvious reason due to this pandemic situation, the remote assistance. Of course, in the last year, the request for a remote assistant for e-maintenance and also for digitalization has really improved, because it's almost is day by day more difficult to go at site, even for small checks, for small work in the plant to analyze what are the issues. Of course, now we are equipped also to provide you support with 24-hour remote support and providing you guidance to do the activity to fix the issues or to prevent the issue even from remote. A predictive and condition-based maintenance plan will allow you to minimize the downtime, to maintain a reliable performance, and to maximize the production between each TA. How this translates? This of course translates in the best and the easiest KPI that your plant wants, which is improving, of course, and increasing the plant profit. So what are the recommendations for a grassroots plant, a plant that recently started operation? Of course, you have to select a qualified supplier for the equipment, the valves, the control system, installation and commissioning. You have to invest time in training the operators. This is vital, very important. In grassroots plant, some of the operators may be untrained, unskilled, and it's very important to train them with equipment, to show them the IOM of a single component, and to explain them where to find help. Then also you have to ask for a periodical professional assessment and survey of the plant, and also the spare part inventory level, even at the beginning of life of the plant. Finally, you have to continuously interact with the valve manufacturer, with the valve provider and supplier, because you may need to ask for best practice improvement about purging system, the valve itself, the control system, and only the OEM can provide such level of details and information. For a plant that, on the other hand, is already established in the service, it's important to plan in advance the turnaround and to understand what is going to happen when you will do the turnaround, which type of units will you service, which spare do you need. And this is very important at this stage, to have a field survey 6-8 months before the turnaround with the actual supervisor that will go on field, and to check the spare part inventory. And then, of course, you need to execute. Execution is made with experienced staff, special tools, and understand that failure to do this will extend the time of your turnaround, will generate problems, pressure, safety risk, and profit loss. Then, once the turnaround is done, what you have to do? Of course, you have to relax a bit, but then you have to restart doing the spare part inventory, sharing the what went well and what didn't went well on the turnaround with the partner, with the technical partner, in order to plan and execute ahead on time what to do on the future turnaround. Finally, we can introduce you the IMI PSP, which is not a game console, but is our Petrochem service pack, a unique and customized maintenance program that will allow you to focus on your life cycle on your equipment. So it's a 3 to 5 years long-term frame agreement, which is composed by a set of survey assessment at field every 6 to 8 months, depending on your needs. So a professional inspection of the unit and the equipment, a real and actual item by item inventory check of the spare, training session at site for end users, and a 24-hour, 7 days per week engineering and after-sales support. Together with this, we have a survey report with the action list to improve the actual condition, the current condition, the action plans for the next turnaround, service and maintenance, and of course, the list of the spares you have at stock, the repair and the upgrades that are recommended for your plant. A win-win solution that will allow you to focus in operating and executing your job at the plant without having any worry and any trouble due to the lack of spare or improper maintenance. And we are done. I would like to thank very much RefComm for the organization and for being so kind in spite of we provided the presentation so late. I would like also to thank Microsoft for rebooting several times the laptop while I was recording this presentation. And so since I don't have the public, I would like also to use this very public sharing. Thank you, you are very kind. As now it's just time for the question and answer. Bye-bye, and thanks again.